Good morning, friends. Today we are going to deal about the helical springs. What are the types of helical springs, and what about the deflection occurred in the helical springs, and also what is the work done on the helical springs, and what is the stiffness of the helical springs. First of all, the case of helical springs. So it is used to find the strain energy stored due to the applied load, either in the case of the axial load or the torsional load or the couple which is applied at the end of the spring. Spring consists of the number of turns and which is having the pitch of either zero value to the maximum value. We can call it as the pitch. In the case of the open coil helical spring, the distance between the two spring wires are having the helix angle alpha, which will be of say 5 degree to 20 degree. So you cannot neglect this alpha value, that is the helix angle. If the helix angle is large, which is called as the tension spring, and in the case of the closed coil helical spring, the value of alpha, the helix angle, will be equal to 0 or it's a very negligible one. So normally it is used to find the deflection in the case of the tension load applied on the spring. So the open coil helical spring, which will be used for the compression spring. So in the case of the practical application is, you can see in the case of a lorry or a two-wheeler or other materials, other vehicles, you can find it used as the shock absorber. So in the case of two-wheeler, either bike or the moped or the any two-wheeler, so even in a bicycle, right, it will be used as a shock absorber. In the case of the closed coil helical spring, normally it is used to find the tension applied on the springs. So here N is the number of turns applied and capital D is the diameter of mean diameter of the helical spring, and capital R is equal to the mean radius of the helical spring. And if you are taking alpha, that is the helix angle, so it will range from zero value to the considerable amount of 15 degree or 20 degree. So based on the helix angle only, we have to find the types of the helical spring, that is open coil helical spring or the closed coil helical spring. In the case of closed coil helical spring, the alpha value is a negligible one, a very small value, 1 degree or 2 degree or the range of 1.5 degree, etc. But in the case of the open coil helical spring, the alpha value is a considerable value, that is 10 degree or 15 degree or 25 degree. So in the case of helical spring, it is also called as the torsional springs. So we are applying an axial load at the end of the helical spring, either opened or closed coil helical spring. So you will get the shear stress. Torsional moment is applied due to the having the axis and the longitudinal axis. The axial load is applied, is converted as a torsional moment, T value. So T is equal to W into R, where capital W is the applied load and R is the mean radius of the spring. Then how to find the shear stress applied in the each section of the helical spring? That is Fs, the maximum shear stress applied on the helical spring is denoted by F suffix S, or you can call it as P suffix S, that is equal to uh, W square R divided by pi d cube into the delta value. So that is the shear stress applied on the springs. Uh, from the shear stress, you can find the strain energy. So strain energy stored, capital U, is equal to half W into delta. We have to find the deflection of the helical spring or the deformation of the helical spring. So due to the applied axial load, W. If you are able to substitute the strain energy stored is equal to half W into delta, you can find the deflection produced on the spring. So deflection or the deformation delta is equal to uh, W R cube N divided by C divided by D per 4. So where small d is equal to diameter of the spring wire and W is equal to the load applied, that is called as axial load, N is the number of turn, R is the mean radius of the coil, that is equal to capital D by 2, that is the mean diameter by 2. From this, you can find the deflection of the helical spring. If once you are able to find the deflection of the helical spring, you can find the stiffness of the spring. So what is called the stiffness of the spring? The stiffness of the spring is defined as the amount of load required to produce the unit deflection. So it can be denoted by capital W divided by deflection delta. So you can get in terms of W by delta, so that is in the case of capital S, or you can put the capital K or small k for the stiffness. The unit of stiffness is Newton per millimeter or kilonewton per meter. So this deflection is used to find the stiffness of the spring also. So like that, you can find the practical problems in the case of two-wheeler or in the case of heavy vehicles. For example, for heavy vehicles like a truck, lorry, or any buses, you can see the spring used as the lift spring. It is not a helical spring; it is a lift spring. Also, it is called as a laminated spring. And coming to the deflection of the open coil helical springs, so what is the stiffness of the helical spring, and how will you find the shear stress produced in the helical spring and the strain energy stored, that we can see in the next YouTube channel or in the next video. Thank you very much for patient listening. Have a great day to all of you. Thank you very much.